The broadcast is now starting. All attendees are in listen-only mode.
Good evening, ladies and gentlemen. Welcome to Tech Geek webinar series, our endeavor to empower techies. We believe sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is to be agile or not to be. That is the question. And today we are having Mr. Srinath Subramaniam as our guest speaker. He is Managing Director at Accenture India. Srinath is currently leading the product engineering group for a freight and logistics product line with Accenture Software. In his over 23 years of professional experience spread across the US and India, he has held a variety of technology management roles, including directing product and engineering organization, driving product and program management, and providing management consulting services for Fortune 500 clients, with employers such as Adverb System, which is a product subsidiary of Infosys Limited, Yahoo, Business Object or SAP, Deloitte Consulting, Oracle, and Westinghouse subsidiary USS. Srinath holds a master's degree in electrical engineering from Utah State University and MBA in marketing and general management from Stephen M. Ross School of Business at the University of Michigan. So without any further delay, I introduce you all to our guest speaker. Over to you, Srinath.
Thanks, Gaurav. Good evening, everyone. It is indeed a privilege for me to be discussing this topic of today with you all. To be agile, that is, or not to be, that is the question. This is meant to be more of a rhetorical question, promoting a discussion on some of the software development practices as they've evolved through the years. But due to the restrictions or constraints of the medium, it's probably not going to be as much of a discussion, but more of a monologue on my side for the first part, and then we could try to have a question and answer session where I could try to answer some of your questions. But if we keep the spirit of the discussion in mind, and if you could note down some of the questions you would have, if this was truly a discussion, I think that would be very useful. So, but before we get on to the topic, let me add a little more color to the introduction that Gaurav just gave. Like a lot of you, about more than 2 decades back, I started my life as a software engineer writing traffic control, railroad traffic control software for a Westinghouse subsidiary called USS. Over the years, I've had a chance to be a software engineer, be a technology analyst, be a business consultant, moving on to product management, and then later on in life, leading teams both in engineering and product management. And these couple of decades have allowed me to see a lot of practices, sometimes lack of practices, but do see a lot of practices leading up, to the agile methods of today. But in all of this, the goal has always been the same. That is to produce high-quality software products. That has never changed. Only thing that we see is there are newer and newer means to that goal. The software process methods that we follow have evolved, have changed. So, that kind of asks us to ponder certain questions. With a plethora of these processes available today for us to choose from, is there a silver bullet? Is there one process that would work for every situation? Is Agile that method? What about the rest? Do we always need to follow only one method? Or can we be very creative and pick and choose from various methods? These are some of the things I think we will discuss today. And rather than give you any prescription of a silver bullet, I hope during the course of this conversation we can try to derive some dimensions for us to say, okay, if we see these kind of dimensions in our context, then these methods may be useful for us. And this is not the end of the story. I'm sure there are going to be newer and newer methods coming up. And so it's always good to keep abreast of what's happening and what is the rationale behind some of those methods and why they've come up and how we can use them. So moving on, I thought this particular topic, typically falls under the realm of software engineering. So let's start with one definition of software engineering. And I have intentionally highlighted, some of these salient points from this definition. There are several other definitions. You can go look up some interviews by people such as Professor Barry Beam of the University of Southern California at Los Angeles, who's given interviews on this topic. He has labs and research that is centered around software engineering, and a lot to say. But this is coming from the IEEE definition. And what I would like you to probably carry away from this is the objective. The objective is to develop software products that meet specifications or the scope desired. They meet it with quality, they meet it on schedule, and they meet it within a budget or cost. So kind of sounds like the 4 constraints that would come from a project management body of knowledge. Very, very similar. Those are the objectives, and in order to meet those objectives, we use a software process, and that is what we're discussing today. Moving on to the next slide, I would like to start off with a little bit of a metaphor. Right? We were discussing about, here are these different processes, and is there a single process that's always right? And here the metaphor is you're looking at a pickup truck, and the pickup truck is a wonderful vehicle. It was meant to do things like carrying a few people and maybe some light goods and taking it from point A to point B very effectively. However, it may not have been meant to do what you're seeing in this picture. A bus would have been a much better vehicle. So this is really a metaphor for sometimes what is the right transportation or right vehicle that you use to achieve your objective, namely to reach your destination. So if you look at software processes itself, there's always been an interest in different processes. But however, in these past few years, it has actually become center stage, especially with a lot of agile methods like extreme programming, test-driven development, etc., becoming very important. In the mid to late 80s and 90s, it was not very uncommon to produce software at a much more spaced out frequency. Most of the businesses were centered around the enterprise software. Internet had really not been born, and most companies of that time, like Oracle, etc., were in the enterprise software business, be it their databases, be it their applications, etc. And again, it was not very uncommon to have a release, a major release once in 2 years, a couple of minor releases in the middle. You would probably also provide some service packs and hot fixes for certain clients who are running into some critical problems. And you adopted methods that software methods that allowed you to deliver to that frequency. Now a lot has changed. Once the internet took shape, in the 90s and started, you started seeing a lot of internet companies such as Yahoo, Google, eBay, etc., coming to center stage. A lot of their methods also took center stage. They wanted to produce things faster and faster. Agility and speed was a lot more important than a significantly large big bang major release. It was absolutely okay to release a smaller set of features, spaced out more frequently with greater urgency than than before. And that meant a lot of the processes and software methods that we used before were not a good fit. So we needed newer methods, and that led to a lot of thinking, and you started seeing the emergence of a lot of agile methods. You also basically saw a shift in mindset from a very planning-driven mindset of the past, of the late 80s and 90s, to a very quick experimentation and iteration-driven mindset of today, and you're seeing it more and more. And that is how things are going to be. So with that as the setup, let's go and take a look at some of the methods. The very first one, I think, is very familiar to a lot of you. It is a very sequential method set through these very well-known phases, starting with the concept investigation, moving on to studying the particular domain, understanding the requirements and analyzing the requirements, moving on to the architecture and design against those requirements for the release that we are targeting, and then going on to code and test it, and then finally deploying or launching it into the market. It followed a very phase-wise flow from one phase to another, and there are very strict reviews at each phase to move on to the next, much like the waterfall that is depicted here, hence the name waterfall that is commonly used to refer to this method. And for a lot of us, this is also the default mindset, because we understand these phases, we understand how these phases flow, we understand what are the deliverables in each of these phases, including the documentation that's required. We've done it for so long that we are very, very comfortable with it. In fact, if I'll try to pepper some examples, at least from my life, to give you a flavor of some of these, and I'm sure a lot of you have your own examples. I had, in the late 80s, like I mentioned, I'd started my life writing railroad traffic control software. And over here, the method we used was loosely based on the waterfall method. The requirements came in from the field because this was software that was really going to control the movement of trains, be it cargo trains or passenger trains. And so the requirements came from the field in terms of the blueprints of the railroad tracks and how things needed to be controlled, where the signals were, how do you, get information from what is there in the track so that you can route the traffic properly, so on and so forth. So the requirements came from the field to the development center. We had this development center in Pittsburgh, and we wrote a lot of code around those requirements. And once that code was written and tested, it was delivered back to the field, for deployment and field testing, after which it became live and became production. And then we supported that production deployment through its sustenance. In some sense, what was very important in those days, because this was the late 80s, was also around the fact there was always a project manager who was very, very key to bringing all of this together, almost like a conductor of music. We all did our things, and the project manager brought it along. That was a very early phase, and then as we, moved along, it took on a more formal shape, like the traditional waterfall and the reviews that you see in this diagram. So, we've continued to move along significantly, with a lot greater maturity, even if some of us practice some form of waterfall today from those days. So, where is this very useful? Even today, this is very useful if the product definition is very stable, the domain is very well understood, and the technologies are also very well understood. And benefits that fall from this are that because things are strictly reviewed as they move from one phase or one stage to another, we can find the errors very early and fix them. However, having said that, this is not a very iterative method. It's a very sequential method, which means if changes need to come much later on in the cycle, for instance, you have a new requirement or a change requirement as you are in the code stage, that makes it very difficult. This is not very flexible for that, and you have to set up very stringent things like change management board and kind of trade off, doing this versus your four constraints. So it's not a very flexible method when requirements change. Somewhere in the mid-80s, at least academically, Professor Beam came up with another model, a spiral model. To be honest with you, I have not used this model, but this model does solve a little bit of the problems of the waterfall model in its inability to adapt to change. The model itself is very strictly laid out into 4 phases. Phase 1 of determining your objectives, phase 2 of identifying all the various risks, the alternate solutions, and finding out means to resolve those risks. And then you develop and test, and then start planning for the next iteration. It is very driven by a risk analysis. So in order to mitigate the identified risks, you will try to build prototypes, study those prototypes, make sure your risks are handled well, and then move on. So risk pretty much determines to a large extent the level of effort. Let me give you an example here. Let's say there is a certain amount of testing you need to do to make sure that the quality of what you're building is good. And let's say this is prototype 1, in our model. Now, while you would want to keep testing and testing as much as you can to make sure the quality is good, you may run the risk, if you elongate too much on the testing side to have perfect quality, to miss the window of opportunity in terms of time to market. So you always have to balance it against that. So in order to reduce the risk of missing the time to market, you probably need to come to a decision on what is just the right amount of testing so that you have a good quality product in the market at the right time. So these are the kind of analysis that you would make. Professor Beam actually calls this to some extent a process model generator. What he means by that is, as you are doing your risk analysis, you may come to decisions on whether that will lead to an incremental development, moving from one set of features to another, dealing with the most risky features first, and then and the less riskier ones, etc. Or you may even decide that in an iterative way you want to do a waterfall. Or you may feel that based on the risk analysis that the best way to mitigate the risk is to do more and more prototyping till you get what you want, like we just discussed. So it is supposed to be good for medium and high risk projects, especially for large mission critical projects. This method is supposed to be good. It's also supposed to be good when requirements are fairly complex and the users themselves, the end users, are very unsure of their needs. So you can use this spiral method of clarity evolution to help them get more clarity into their needs and gather the requirements more precisely. This is also supposed to be good sometimes when you're trying to launch an entirely new product line where you have a concept in mind, but beyond that a lot of things need to be worked out. Definitely benefits fallout because risk analysis takes center stage. Risk reduction is a key value. So this would be a benefit that comes through it. Software gets produced early. So, and you would also seek early feedback from customers or significant stakeholders. So that gets into the product early so that you're not releasing something to the market that the customer didn't want. Unlike some of the previous methods like the waterfall, functionality can be added later because we have a very incremental way of, an iterative way of developing. However, having said that, there are certain things that you need to bear in mind because this is so driven and so centered around a risk analysis paradigm. You would require specialized expertise for risk analysis. That's center stage. If you don't do that well, then clearly this software process model falls out. Also, because of this very involved nature, it's sometimes very complex and very costly to implement, so it definitely would not be a good fit for smaller projects. So moving on, one of the things actually before I move on, a question that I want to ask you is if any of you have used this model, and if so, could you share with the rest of us where you've used this model and how you found this model in whatever form possible. Share it to the moderator who will then share it with me, and later on once I wrap up, I will probably share it with the rest of the audience. Moving on, from the spiral model, let's move on to the evolutionary prototyping model, which is again something a lot of you may have done, especially people who are maybe working in startups, early stage. You have a concept and you want to thrash the concept out. So unlike the spiral model, this is fairly simple. It is not a very complex process. You start off with that initial concept and build a prototype that matches that initial concept, and then seek feedback from your customers on the prototype that you built to see if they see it the way you see it, and then get more requirements from them, get more clarity on your side, refine the prototype and keep building on it till it becomes acceptable as a product release, and you could at that time release the product to the market. Once again, this is very, very good for very early releases. This is something that I followed when we were actually spun off as a wholly owned subsidiary of Business Objects. We were trying to do something in the realm of what we call analytical applications in the late 90s. Today it's probably more commonplace, but at that time we were just in the early stages of business intelligence, even on analytical applications. So we were trying to build some prototypes, get a mind share with some of our design partners. We had a couple of very leading players in the e-retail and telecom space, and we were trying to get feedback from them and evolve the prototype and then have the first release to the market. Thing to note is, again, the first release we didn't target the whole customer end user base. We were very clear that this is something that's going to percolate its way down to the larger base. So in the early days, it was targeted more to providing the kind of insights to the CXOs and then going down the user pyramid. So again, as we were doing this prototype, we were also trying to interact with the needs of the CXO type of user. So having that clear is also very important. So definitely benefits, you get immediate feedback through your prototypes to understand whether the concept you had in your head is a good concept or not. But some of the things you want to bear in mind is sometimes you can get carried away with this slightly looser style, so it may be difficult to plan. You don't know how many iterations you want, and then you may kind of get into the trap of coding and fixing, so you may start having deterioration in quality. So again, this is not something that you want to do, especially with a less experienced workforce later on in life. The early releases, you may say, is more about mind share, but later on you definitely need to be industrial strength. So need to be sure that you have the right team to do this if this is something that you'll follow. Again, it may be good for smaller kind of releases, may not be the way you would develop fairly large scope products. Okay. Moving on. We move into something, again, a lot of people may be very familiar with. This really started with, the object model movement and unified software processes. And this was a very popular thing from Rational called the Rational Unified Process. It emerged as a very common development method followed by a lot of companies, especially in the mid to late 90s and early 2000s, at least in the US for large enterprise software companies. One of the USPs of this is it has got good visibility into how business value is being delivered through cycles and iterations. It's laid out in well understood phases. You can see that over here. The phases being inception, elaboration, construction, and transition. Inception is largely around getting initial estimates on costs, initial estimates on budgets, creating our initial plan, creating a vision for the product concept you have, having some initial scope in place. So you can clearly see, because it is centered around these kind of activities, there is a lot of intensity in business modeling and requirements gathering in the inception phase, more in the business modeling side. But then when you move on to elaboration, elaboration is taking it from here and trying to do a domain analysis leading to getting some of the requirements in place and some form of a basic architecture in place. So you kind of see that in the elaboration phase, we have far greater intensity in requirements gathering, analysis and design, and some beginning of development, probably prototype development that you may choose to do during the elaboration phase. Construction, as the word clearly signifies, is more around building and testing our software against these requirements, following the architecture and design that has been laid out. Again, this is in different iterations, and you can see that the implementation is what takes greatest intensity in the construction phase. Test, of course, also takes a lot of intensity in the construction phase, but in the spikes that you see, whenever a certain size of software is available, you would do a lot of testing around that. Finally, once we reach a level of stability to release the software to the market, we move on a transition to the transition phase, which is basically moving it to production if it is an enterprise application, or launching a product if it is a tool or commercially available software. This also follows, a certain method of cycles and iterations. So let me kind of explain that through an example. So let's say you are building banking software, So you may break that into multiple cycles. Maybe in cycle 1, you may deal with only a set of use cases or functionality that is centered around basic withdrawal facilities, and you will build that. And you would do that through these 4 phases of inception, elaboration, construction, transition. Here, when you're transitioning, you're not necessarily transitioning to an external customer. It's more of an internal milestone. And then you may choose to have a cycle 2 where you may add more functionality and use cases or functionality centered around account and system management. Again, going through these 4 phases of inception, elaboration, construction, and transition. Again, this transition also being an internal one. And move on to, let's say, something like a cycle 3, which is full account management and cross-selling, etc., etc. So you follow these process of cycles and iterations till you hit your product release goal, and you release the product, now to the external customer. In this method, things are very well laid out. You have tools, you have methods, you have templates, you have very strict reviews at different points for go, no go. It's again very well laid out, very well understood. If you get trained in it, it's very successful to build large projects and large software products through this. If you recollect, I was mentioning to you that in the early days we kind of used some form of evolutionary prototyping for our analytical application, but as we started hitting our midstream, when we started having a lot more customers and a significant revenue line, clearly that evolutionary prototyping wouldn't work. Industrial strength was the order, and we actually moved to adopting the rational unified process. It worked very well for us. So looking at things that are very useful here, it's time-boxed, it's iterative, it follows this beautiful method of cycles and iterations. Everything is very well laid out, so it's really easy to manage large projects. But having said that, if you have some smaller projects or even maintenance release like we had, this may be an overkill. Some of these templates are very involved and it may just be an overkill. The other thing is it's very, very important to get trained in this process. Knowledge of this process, knowledge of the methods, knowledge of the tools, knowledge of the rationale behind every phase. All of that is very important. And the whole team needs to understand that well so that you succeed with this process. So moving on, I think we can start looking at some of the agile methods that have evolved. But before we go there, I just wanted to kind of throw an idea at you all, which is till now all of these methods worked against one central paradigm, and that paradigm was if we caught errors, if we caught changes early, then we could keep costs low. But if we caught these changes and caught certain errors which would lead to further changes in product scope much later in the game, then costs significantly changed. So the question is, as we start moving into the current era of having to release things very, very quickly and not sometimes having the time for some complex methods, is this paradigm really true? Is it possible for us to really flatten the costs? For us to see if there is a way that no matter when the changes come, we are still able to control our costs and keep it, optimal. So those are some of the things that some of these agile methods, which are very iterative in nature, lend itself very well to. So going from that equation of, finding things late means more costs to it's okay, you can have changes anytime in the cycle because we are following a method that expects that to happen and can react to it. So, there is a whole bunch of very influential people who laid out a manifesto, and most of you would have read it, but without going into the manifesto, I think some of the principles clearly that they emphasized on is emphasizing on people over processes. They emphasized on the iterative approach. They, in some of the methods, they focused on code over having a perfect detailed design ready. Code and then see how things evolve. Keep it simple. They focused on the fact that customers and stakeholders' involvement was very, very critical to the success of these projects. They focused on the fact that we should expect that requirements will change and we should be able to react to it. And they focused also on the fact that simplicity is the best innovation. So keep things as simple as we can so that we are able to react to things very easily. So Agile was found to be very, very suitable, these methods, when customer involvement is very high. In fact, you could argue the business users are pretty much an integral part of the team. It was also found to be very suitable if the customers had great maturity, especially when we are following a distributed delivery mechanism. It was also found to be very suitable when automation is possible, so that the whole build test deployment cycle can be automated as much as possible. And it was also very suitable when we can actually look at requirements and split them into user stories, which can then be built in iterations, leading to this whole concept of iterative development. And by contrast, it was not very suitable if business users availability, was a challenge, lower than required. And if you, one of the principles in these methods was to build a shippable product at the end of every mini cycle called the sprint. And if there is a challenge in doing that, then again, this may not be suitable. And clearly, you would need to work towards a mindset change with the team itself as well as the customers. And if that is a challenge, then you would face roadblocks in your journey. And if automation is not possible at all, again, it would throw up a whole bunch of challenges. So bearing that in mind, let's take a look at some of the methods. A lot of you, I think, would probably favor this method called extreme programming. I'm going to read a quote from Kent Beck, who was one of the early founders of this mechanism, and he was one of the 17 people who were very influential in the agile methodologies, including creating the manifesto and so on and so forth. And he says, XP is a lightweight methodology for small to medium-sized teams developing software in the face of vague or rapidly changing requirements. So he also kind of goes on to say, if we had all the time in the world to program, then we would probably choose some functionality, write some tests, write code for that, and restructure that code. Often talk to fellow programmers, get their thoughts in, and keep building our code such that it produces something of value, which would be a small release, and then we release it to the market, and then keep moving on. These are some of the things that you get to see a lot, what he says in this method. Values are definitely around communication. That's very important. Small teams, communication. You see principles like pairwise programming, having customer feedback, all playing a role, in building, this communication through. Simplicity, you plan and build something and deal with the changes, as they come. Don't worry too much about the kind of things that you did in Spiral, which is, very intricate risk analysis and so on and so forth. Let's not worry about that. Let's keep it very simple. Let's code. Let's test it. If it meets our criteria, then let's release it, right? Clearly also emphasize the value of feedback. We talk to customers, get their thoughts on what we are building, put it into test cases, and build and release against those. Another value which is very important is courage, because you are saying, I'll write code, I know what I'm doing, I'll write code and I will release it. So sometimes you may have to throw away something that didn't work out, and you may have to have the courage to restructure code very often, change things very often. So those are all the things, that you definitely should bring in as you're looking at this method. Techniques that you can use are, just having incremental planning, having small releases, having just simple and just enough design, doing some test first development, refactoring the code to improve the quality, do pair programming, and then emphasize the principles of continuous integration so that the whole pipeline moves through very smoothly, and if possible even have a customer with you so that he or she is an integral part of the team. Some of the places where we found this to be very useful is, hiving off, certain technology initiatives, that are part of the roadmap. Like sometimes re-engineering for a newer technology, or focusing on a performance improvement project through a technology overhaul, and technology refactoring, etc. These kind of things can be hived off into smaller things, and then you could follow this process. the extreme programming process. And extreme programming itself, as you will see, also lends itself very well into the Scrum method also. It can be an integral part of how you do. And that takes us to Scrum, which is probably one of the most popular Agile methods and very commonly used. Most of you would have seen this kind of a diagram. 3 phases: an initiate, build, and deploy phase. Though don't think of it as a very strict thing like the the waterfall. What's important here are the actors. A product owner who sometimes is the business user, and sometimes the product manager who's responsible for the what we're trying to do. The team itself, which is largely what we call self-organized, which is going to build the product out, and someone called the Scrum Master, who's kind of like the orchestrator or the conductor, who kind of facilitates and makes sure things are moving iteratively towards our destination of the product scope. There are processes and collaterals that are very, very important as we follow the Scrum method. A product backlog is at the heart of it. The product backlog is a living, breathing document which kind of captures what it is that you want to build, and it's kind of sometimes referred to as the list. That's what you are planning to build. It's a capture of all of that, and that forms the source for creating, once you prioritize the product backlog, for creating what is called the sprint backlog. The Scrum itself is broken into several sprints. A sprint can last anywhere between 2 to 4 weeks. Most people say going beyond 4 weeks may not be very advisable. And in those 2 to 4 weeks, the goal is to produce an output that is possibly a shippable subset of your product, definitely demonstrable. At the end of the sprint, you are expected to demonstrate that output to your customers and stakeholders and seek their feedback so that you can refine it. So through these iterations of sprints, you get to delivering your product. So while you're doing the sprint, again, from a process perspective, it's very important to have a daily stand-up, very short meeting, which discusses what are the things that were done, what are the things that are planned to be done for the day. So call it a daily sprint if you'd like. And what are some of the challenges and where help would be needed. They usually keep it to just those 3 things and keep it very, very short. Then you do have sprint reviews and sprint retrospective meetings at the beginning and end, to plan for and also look back. And like I said, at the heart of this method is the whole sprint-based development mechanism. So this is something which we are seeing very often in a lot of companies. Definitely something that a lot of the consumer internet companies have adopted very, very successfully, so that they can start trying to hit what they call release trains with frequencies maybe as little as 3 months, 2 months even, where they can release a smaller set of features to the consumer and seek feedback and iterate. And that sense of speed, that sense of agility is also started flowing back into the enterprise world. So you start seeing a lot of the enterprise software companies also adopting some form of Agile. Scrum is usually where they start, and and they're having a lot of success with it. Again, when you look at this, it's very, very useful when requirements are very fluid. So building product backlog and combing it into the sprints, in an iterative fashion is very useful. It's very useful for small projects, that you can deliver at greater frequency, and it's very useful when customer feedback becomes a very integral part. And by that very token, you're building something that the customer wants. The danger of building something that a customer doesn't want is substantially reduced in these methods. Again, it can be very hard for large projects. It's better to have smaller teams of 4 to 9 people doing the Scrum, because if it becomes very large, then it becomes very hard to manage. You definitely need a good balance. You do need a lot of experienced developers because this is largely self-organized, not the command and control methods of the earlier thing where a manager tells the developer what to do. Here, the developer actually says, this is what I'm going to be, this is the user story, or this is the task I'm going to pursue, and moves it through a progress chart from something that was not started to something that has been validated and delivered and moved to production. So clearly, having a good mix or a good infusion of experienced talent helps, especially in the early iterations. And customer input is very, very key. If that is a challenge, again, Scrum or any Agile method may not work very well. Moving on, I'm going to go through this a little faster because I think there's probably 13, 14 minutes left. So Agile then moves on to the concept of a distributed Agile. Sometimes not everyone is in the same place, and you may need to do development, you may need to do product definition in a distributed manner, and so leading to a distributed flavor to Agile. And we look at some scenarios. I think these are some of the common scenarios that some of you would be seeing in your work. Challenges to distributed Agile. I'm just going to show this. I think it's clearly something that a lot of you may be familiar with, especially if it's distributed and if it's across cultures, dealing with some of these things as cultural differences, time zone differences, not being face-to-face, etc. Could be a challenge, so we need to pay special attention to it. This next slide I'm showing is just kind of to emphasize the fact some of these softer things like cultural differences are very, very important because especially in the early days as you're trying to work with customer teams which may be located in a different country with a different cultural background, it's very important to understand the culture. And this this cartoon of something that we all sometimes use to say excellent in India may mean entirely different things in different countries. In fact, I have a senior partner that I report to in our product practice within Accenture. It was very interesting talking to him. He's from the Midwestern part of the U.S. and he said, I asked him, what is the one thing that you've learned, in all of these years of working with Indian programmers? And he said, I've learned that there are different meanings to the word yes, and I think hopefully it will get a chuckle from some of you. But yeah, I mean, that's kind of the cultural nuances that you need to be very, very aware of, especially as you're embarking on distributed Agile across cultures and geographies. Okay. So model one is relatively simple. Everyone is co-located. This may need not even be distributed. The only reason it's distributed here is because of the separation between client and the vendor. The team works directly with the product and business owner, and everyone's kind of in the same place. So it's much easier to manage requirements. So this is also very important if requirements are very, very critical or confidential, such that things can't move out. In such cases, you may be forced to do a co-located distributed delivery model. It's also very important if you have the budget to do it if the business users are not easily available. So being there kind of gets you more time. But moving on to more distributed methods, you could have a model 2 where the development team is on the remote side, and the product owners, the business users are all local. this method works very well, if the requirements are simple. The remote team also has a very good knowledge of the business functionality, and the business users are very well available. Because if these things don't get met, this model could be a disaster. Moving on to 3, where requirements are not simple, it can be complex, or the remote team may actually have only limited knowledge of the business functionality. You kind of put a local layer here, which includes the business analyst and the tester, which is called the feature team, so that they act as a bridge between the client, and the remote development team. So they reduce some of the risks. Finally, you may move into model 4, where you actually do what some of us sometimes call Scrum of Scrums, which is parallel development. You may have a local team doing some set of features and a remote development team doing another set of features. This is especially true when the entire scope itself can be divided into 2 parts. One part which needs to be local because of criticality or confidentiality, and another part which can move remote. So in situations like that, you may choose to do something like this. Again, this also may be useful if the requirements are complex and not very well defined, and you can kind of use this method to partition which requirements get done where, and also have the business analysts help in the report team understanding things better. So when we go on to these kinds of distributed methods, it's very, very important that the collaboration tools are, play a very, very key role in release planning, in sprint planning, in the daily sprint activities, so on and so forth. There are a plethora of tools, and you would be surprised that, some surveys, part of which, I'll be sharing later, so that a lot of people still use Excel or Microsoft Office productivity tools, though tools like Atlassian, Jira, etc. are also gaining a lot of popularity. But, having a very strong tool suite is very, very important when you do these forms of distributed Agile, so that collaboration can be very effective. So again, a slide to just highlight the point. A lot of you who are involved in distributed Agile probably recognize this, especially as we are going against East Coast time and India offshore time. Having a daily stand-up meeting at the beginning of India time and then having an end-of-day wrap-up will help things. Communicate more often, and communicate again. That should probably be the principle, when you're collaborating across geographies and time zones in this manner. So some statistics that may be useful for you. This is coming from a survey that was conducted. You see the link below. This was largely US and European customers. 52% of them said they were using some form of Agile, and out of that, as much as 38% said 76 to 100% of their projects are following some form of Agile. This is fantastic, because five to 6 years back, when I was first trying to do Agile, in fact earlier, 8-9 years back, when I first trying to do Agile in Yahoo, when we were all moving to that, it wouldn't have been numbers like this. Again, if you look at the people who are most conversant with Agile, no surprises there. The Scrum Master usually tends to be the person who's the most conversant, going all the way down to the BA, who may not be the most conversant. Moving on, some other things, leading causes of failed Agile projects. Again, no surprises here. Things such as culture, things such as mindset, things such as pressure to follow a different method, so on and so forth, seem to be taking prominence there. If some of you have run into other reasons for failure, if you could share that again, that would be great. That would be great. Again, looking at some of the methods, no surprises here. Scrum seems to be the most popular method, and some variant of it. It almost accounts for 73% of the methods followed. So again, I will skip through this slide. This was just to give you a visual depiction, laying things out side by side between these different methods. How it may look, and I think this this slide is self-explanatory. So comes down to the crux of why we were discussing all this. So hopefully through this discussion, you probably already derived some of these parameters, right? What method is right, what is apt, is a factor of some of these, right? Requirements understanding. How much understanding is there? How much clarity is there? Is it very well defined? Is the domain very well understood? Are the technologies very well understood? Then things such as waterfall may still, and is the project really large? Things such as waterfall may still be valid. What is the expected lifetime? Is this a very short, quick, and dirty thing that we could do probably with something like XP, or is this something that's going to have a very, very long lifetime? What's the level of risk involved here? Can we do an analysis, and if so, based on that, what are some of the things that may fall out of that? What are some of the schedule constraints? Is this one of those things where we can throw resources and deal with those constraints? Again, those are the kind of things. How much access do we have to customers and stakeholders? What kind of interactions do we expect? Are they readily available, frequently available, or are they very hard to get hold of? Again, these are things that will lead us down a path of some of the models like rough versus some of the models like Agile. And again, availability of expertise becomes more so when we start following methods like extreme programming. Do we have a good, strong, highly experienced and highly expert team, or not? On the business side, do we have experts who understand the domain very well? These are the kind of things that you would ask, as you lead to what the right model is. Leading to, again, this table, which is more a summary of a lot of the things that we discussed. Look at each of these models. What are some of the advantages and what are some of the disadvantages, and therefore, how do you pick which one is the right one, to follow? It would be nice to end with a quote. We started with a cartoon that you all saw, but I didn't really discuss much. But a quote which says, I love deadlines. I love the whooshing sound they make as they fly by Douglas Adams. A lot of you may have read his Hitchhiker's Guide to the Galaxy. Hopefully, if we get our software methods right, if we choose the right method for the right context, hopefully using some of the things that we discussed today, then none of us here will hear that whooshing sound. With that, I will close and look forward to questions that may be coming my way from you all.
Thank you, Srinath. Before moving to the question, do you want me to run the poll?
Well, I thought I will skip the poll because of time. Do we have time, Gaurav? If we have the time, we can run the poll.
No problem. We can. We'll extend session for 10 minutes. That's not an issue for us. So you want me?
Okay. Yeah, that will be great. I think the poll will be very interesting. Gaurav is going to run a poll. What I was planning to do was I showed some data around adoption of Agile, but that was largely centered around US and European practitioners. So this poll is more to see how it plays out using all of you as a sample. So if you can go on and run the poll, that would be great, Gaurav.
Srinath, can you
Yeah, I'm beginning to see some. Yeah, I'm beginning to see some results of the first poll. 65% of the people say they use some form of Agile. 22% say no, and there's about 14% that says there are plans to use Agile. So that's fantastic. I mean, it's even better than what we saw there, which came um, from almost 1,000 odd practitioners in the US and Europe in 2013. So that's the latest survey. So this number looks even better. So clearly, we are at the edge of the software wave and at the edge of the models that we adopt. Gaurav, could you maybe ask the second question, the second poll question now?
So Srinath, we have result for the second poll.
Okay, I'm not seeing it yet, Gaurav. Maybe there's some glitch. I'm not seeing it in the chat window yet. Okay, it's just beginning to flow in. Sorry. So for this question, the answers seem to tally to less than 25%, about 24% of the people said they fall in that category. Between 25 and 50%, about 50% said they fall in that category, and about 18% said 50 to 75% of the project, and over 70%, 9%. Everything is, as I said, 13%. My math may be a little wrong because maybe one of those numbers is not right what I read out, but these are again good numbers for us. I'll also there are a couple of questions that I see. I think one is more of a comment from Ramendra Singh. This may have been when I asked if any of you is using the spiral model. Ramendra Singh says, yes, we use it in our current project. It's slightly different, but the idea is around the same. Unfortunately, again, if this was a discussion, we could have had Ramendra share with us what he meant by that. But it's interesting to see that there is, definitely one person who has used this. There is Lakshman Subramanya who says, am I wrong if I say there's a mini waterfall model embedded into each iteration of the iterative methodology? As we were discussing, you're absolutely right, Lakshman. As we were discussing the spiral model, Professor Barry Beam actually says that depending on the risk analysis, we may actually spiral out into the waterfall iterative waterfall models. That may be the decision we may take for risk reduction. Then alternately, if you look at RUP2, the cycles and iterations, kind of loosely a larger iterative thing, and then this phase-wise thing, inception, elaboration, construction, and transition is not very, you could derive it back again to what we do in waterfall from concept development to requirements and analysis. You can kind of tie it down. So yes, you're right. Again, these are all models. Here is what you have, in your menu card. Rather than buy a pizza that's already made for you, I think you should study your context and maybe even create your own. And I think a lot of times that's what we do. In fact, in my current project, I would actually say it's hybrid. It's some parts are very agile, some parts we may be waterfall around the edges and very agile in the middle. And I think a lot of you again may be doing things like that. Then there is a question around how is agile method feasible for fixed cost projects. Most of these projects are estimated between 200 and 600 hours from Prashant Sonwani, but he has left. I think, again, there's a whole bunch of parameters that we looked at. Clearly cost is one of them, but I think it's absolutely possible for us to do Agile. In fact, we in Accenture have a significant portion of our projects following Agile, some of which may be fixed cost. But again, you have to study all the dimensions and see what works best. And again, it's not a binary thing, Agile versus non-Agile. Like I said, we personally have some kind of a hybrid, and that seems to work best for us. And so even in a fixed cost, you may choose to say that I may do a traditional waterfall for requirements gathering because it's largely, especially in a services context, largely coming from the customer. And that would be waterfall. The concept, the requirements, a lot of it is driven by the customer. And then when my development, which is build and test, code and test starts, I may organize it around sprints because I want to see, break those requirements into smaller chunks. That is my product backlog, and I break it into sprints and I sprint. And once I finish my testing and then I start having to go, especially in a services context, like I said, to do systems test with the customer and user acceptance test, etc. Again, I may flip back into a very traditional waterfall method. So yeah, I mean, you can definitely use Agile principles within these projects also. What else is there? There's a question from Dina Sharma which says, how much inception affects the software testing at initial phase? See, inception, as you recollect, is where we are taking our first stab at what is the vision for the product, what are, some of the plan-related things, what are some of, you may even get to build an initial prototype for validation as you progress into into the elaboration phase. Again, if you recollect, we said we follow a cycles and iterations methodology, especially in RUP, which is probably what Reena is referring to. So again, you may choose to say, I have all of these requirements, and I'm going to categorize them based on a bunch of dimensions like priority, criticality, complexity, etc. And I will say, here are a certain set of use cases that I will target, for the first cycle, and in that, again, that iterative method itself, will lead into how you plan your, testing and how quickly you can find your errors. So again, the testing itself is a part within a cycle, and each cycle will have its own testing thing in its construction phase. But the prototypes that you build, the use cases that you thrash out, all of that will clearly affect the testing that happens, in the construction phase. How do you find errors early in the waterfall model? Here, this is coming from Narasimha. Narasimha, the point here was that because this is a very phased method and you have very strict reviews as you go from one phase to another, the understanding is when you finish your requirements and analysis phase, and that is signed off by everyone after analyzing, the requirements should be very good. If it's done well, it should be very good, and the errors that usually creep in because certain requirements are either not comprehensive or complete or correct. So if you do the reviews well, you are able to mitigate those risks and therefore you find it very early in the requirements and analysis phase itself before you even start designing or coding. That's basically what that meant. What are the most popular statistics reports metrics used by PMs and Agile projects to know the health and progress of the project? From Lakshman again. Lakshman, burn down charts and progress charts are very, very popularly followed. That's definitely something that you would start off with. In fact, I would suggest for some of you you could probably go to YouTube and see some videos. And if you want to get a little chuckle, there is a sitcom that's just finished season 1 in the US called Silicon Valley. And one episode there kind of focuses on Scrum and the introduction of Scrum to extreme programming, development, release it kind of developers, the quote-unquote the typical nerds of the Silicon Valley, and how they react to Scrum and how they go on doing it. So in that particular episode, you actually get to see some progress charts and burn down charts and all of that stuff. But those are where you'd probably start with. More centered around, burn down charts, as you delve further, is more centered around how much is left rather than, effort estimation and, so on and so forth. So this gives you a greater indication of how you're proceeding to your destination. As you see one of those example charts, it will become very, very clear to you. Can the project manager and Scrum Master role be combined? Many Indian companies are advertising for a project manager, Scrum Master from Nilima Prabhu. I think you're right, Nilima. I think in a lot of places that's what happens. However, some of the advices, especially when you're embarking on Scrum for the first time, the temptation is to make your engineering manager a Scrum Master. But you have to be very careful with that, because in your previous method, your waterfall method or some of the earlier methods, your engineering manager would have been very used to the command and control mindset, where they clearly say, okay, go ahead, do this, right? This is a very democratic setup. Like we said, the core of this is it's a self-organized team. People over processes was the central value, which is there in the manifesto also. So you need to make sure that who you choose as a Scrum Master is someone who's more of a facilitator, not a director. That is what you have to be very careful about. So if your project manager can be that, then yeah, clearly that is a person who can play the Scrum Master role. But if the project manager is someone who's used to saying, okay, this is done, blah, blah, is constantly being a driver and a director, then it may not work very well, especially in the early days as you're trying to make that shift. Can you please explain detail about sprint, design, analysis, build, test of Scrum? From Lavanya, could you please explain detail about sprint, design, analysis, build, test of Scrum? I'm not very sure. Let me take a stab, Lavanya. Hopefully I am addressing what you are asking me. See, like we said, this is a self-organized team, right? So they work against certain user stories. So the QA, the development, all of them, the product owner, the Scrum Master, they're all part of the same team. So if you have a set of user stories, and let's say, each person then says, I will be working on this user story, be it a developer, be it a, a QA person, so on and so forth. In this sprint, this is what will be done. This is what I'll work with. So the sprint encapsulates everything, everything that you would see in a traditional waterfall model, from, the user stories being written, developed, unit tested, tested by the QA, and, becoming a demonstrable product at the end of a sprint, and potentially even shippable. At least that's the goal. In a lot of real world, in the trenches kind of thing, what we guys have traditionally done is, if we, let us say, we have a 3-month release cycle, and let us say in that 3 months we divide it into 5 sprints. Then we may have 4 sprints where we are doing a lot of development, and 1 sprint where we may do what is called stabilization, doing some of the performance testing, um, and other kind of NFR testing, so on and so forth. You could do it that way, but in my previous company, we even experimented by front-loading some of that. While you still may need sprint 5 to do the stabilization, are there certain elements of the NFR aspects which can even come in the development sprint cycles itself, so that what is left is just one last set of testing. So hopefully that does address what you were asking, Lavanya. I think those were the questions I have as of now, and with that I will hand it over back to Gaurav.
Thank you, Srinath, for such an insightful presentation on Agile process. I am really thankful to you for taking so many questions and conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on our website in next few days. Thank you all. Have a nice evening. Thank you, Srinath. Have a very nice evening.
Thank you.